For WebAssign 8.1 grams to moles to atoms. And I won't go over all of it because it will take a long time if I do that. You can also find the worked answers in the Google Classroom. Just keep in mind that you may be given a different element or you may be given a different starting number, but the process should be the same. So question 1, there are blank yttrium atoms present in 88.91 grams of yttrium. So you got to look at a periodic table and find yttrium. And yttrium, it says the mass is 88.906. This is a little bit like a trick question. So 88.906 would round to 88.91. And the mass of every element on the periodic table represents 1 mole, and 1 mole represents Avogadro's number. Therefore, it's 6.022 E23. You don't have to put that plus in there for WebAssign, but you could if you wanted. But again, you'd probably need 6.022 and E and then 23. And that E means times 10. So let's go to question number 2. So use average atomic masses to calculate the number of moles of the element present in each of the following samples. Be mindful of sig figs and other units. For example, milligrams must be converted to grams before you can convert to moles. So the very first one is 66.95 grams of fluorine, and we are trying to go to moles. So we'll write 66.95 grams of fluorine, and it's just F. I'm going to do my railroad track. And if I have grams on the top, I want to get rid of it by putting it on the bottom. And there is a relationship between grams and moles. And so far we've learned that next to the mole is always 1. So 1 mole of fluorine has so many grams. And this grams you'll find from the periodic table of elements. And fluorine is 19.00 grams. And then you'll plug it in the calculator. It will be 66.95 divided by 19 equals a number. I'm ignoring that 1 on the top because when you multiply by 1, you still have the same number. I take my shortcuts when I can. So 66.95 divided by 19, I have to have 1, 2, 3, 4 sig figs, and my final answer is 3.524 moles. And you'll plug that number in there. And you can see on this sheet here, it actually gives you what the answer is. I'm just showing you so you know when you plug it in, if you follow along from these numbers, to make sure you know how to use your calculator to get the correct number. Let's do the next one. The next one's a little bit tricky because it gave you milligrams. And when we do grams to moles to atoms, you always have to be in grams. You can't be in milligrams. So 404.2 milligrams of mercury, MgHg. You could also write it like this, but just keep in mind you know that that is over 1. And we have to change milligrams. So I'm going to put milligrams on the bottom and grams on the top. And 1 gram is 1,000 milligrams. And that will get rid of our milligrams. And then we have grams, and then we want to go from grams to moles. And these are moles of mercury. 1 mole of mercury has a certain mass. I'll look at the periodic table of elements, and the mass of mercury is 200.59. It's a heavy metal for a reason. It's got a lot of mass. And in my calculator, I'll go 404.2 divided by 1,000 because 404 is on the top, 1,000 is on the bottom. I'll hit enter. And then I will divide 200.59 into that answer because it's still on the bottom. So if you're like me and I take a lot of shortcuts in my calculator, I would do 404.2 divided by 1,000 divided by 200.59, and then I would hit enter. And we started with 1, 2, 3, 4 sig figs, so we should end with 4 sig figs. It looks like this answer is 0.002015, 2015. Make sure you have that there. You could write it in scientific notation also, and that's moles of mercury. Let's skip down. Let's see if there's another tricky one on here. I don't see one, but let's do molybdenum. This one is 48.15 grams of Mo, Edgar Allan Mo. I'm going to do my railroad track. I can go directly from grams to moles. I'm going to remind you when we're working with individual atoms that you can do GMA, grams to moles to atoms, or you could do atoms to moles to grams, but you always have to go through that mole hole. And I have grams on top here. I want to get rid of grams. It's going to go on the bottom, and I'm going to go to moles. So far we've learned with mole, the number is always 1, and this is 1 mole of Mo. And then we're going to look up the grams for the periodic table of elements of Mo, and Mo is 95.94. I'm going to cancel out my units that cancel out. I'm left with moles, which is what I want. In my calculator, I'll do 48.15 divided by 95.94. It looks like I have 4 sig figs again, and my answer should have 4 sig figs. Remember that leading 0 in the front is just there to hold a place. It does not count as a sig fig. Let's move on so we have enough time for all of this. Question 3 says use the average atomic masses to calculate in grams given the moles of each of these. My dyslexia is coming out. So the very first one, we have 0.271 moles of lithium, that's Li, and we want to go to grams. So grams to moles to atoms, we can go that way, and we can also do the reverse. So if we're at moles, we can definitely go to grams. I'm going to do my railroad track. If I have moles on the top, I'm going to put moles on the bottom. So far, mole always has 1 next to it, and this is lithium, which is Li. The grams, which I'm going to find from the periodic table, which is 6.941 grams. Those two numbers are next to each other, so I'm going to multiply them. And I need to have 3 sig figs in my final answer. Again, it's based on your starting number. So 0.271 times 6.941 is going to give me 1.88 grams of Li. And again, I'll go put that number in there. Let's look at these and see if there's another one that's a little more challenging. I think they're all about the same. Let's do this lead one because it looks a little bit different. So 8.66 times 10 to the minus 2, you could write it as 8.66 e minus 2, or you could just move that decimal over twice. 1, 2. So it would be 0 and a decimal, 0.866 moles of lead. Lead is Pb, it looks like peanut butter, or plumber's butonkus. We have moles on the top. We want to get rid of moles. We'll put it on the bottom. The number next to mole is 1, and this is lead. I write that down so I remember when I go look at the periodic table what lead is. Lead is another one of those heavy metals. 207 point, very big point, 2 grams for lead. Those two numbers are next to each other, so I'll multiply them. I'm ignoring the 1 on the bottom because if you divide by 1, you still have the exact same number. And started with 3 sig figs. Remember, those zeros don't count, so 17.9 grams of lead that I would go and type in there. So for all of these, you're going to multiply by the mass on the periodic table. Let's go to number 4. Calculate the number of atoms of aluminum in 84 moles of aluminum. There's a lot of repeating words in there. So we are given moles, and we're trying to go to atoms. Aha. So grams to moles to atoms. We're here at moles, and we're trying to go to atoms. So I'm going to write down 84.0 moles of aluminum. I don't need to look at any periodic table for this. To go from moles to atoms, again, my atoms will be on the top because that's the one I'm trying to find. Moles will be on the bottom. And so far, everything we know about moles and atoms is 1 mole of any element or anything has 6.022 times 10 to the 23rd atoms, or parts is what it is. A mole represents 6 times 10 to the 23rd parts. 1 is on the bottom. Those two things are next to each other. I will multiply them, and it should be a ginormous number. It looks like it's 5.06 times 10 to the 25th atoms of aluminum. Try counting those with your eyes. So you have to remember how to use your calculator. You cannot plug in with 6.022 and just find the letter E on there and put 23. You will not get it correct. And some of you will be tempted to go 6.02 hit the times button, put a 10 and a caret and a 23. That's all good if you know how to use your calculator. You can only plug it in that way if you have parentheses around that. Otherwise, it'll carry the decimal either to the left or to the right too many places, and you won't get the correct number. The easiest way to do it is 6.022. You will hit that second button, and then you'll hit the comma button. That above that comma button, that's what you're trying to access with that second button, is EE, which is the scientific notation. And then you'll type in 23. And it looks like 6.022. The calculator pops out a big E and a 23, and that means times 10. The E means times 10. That's what I do. I do not mess with the actual times button or the caret button. So you have to know how to use your calculator. If you don't know how to use your calculator, when you get on the test, your chances of doing really well diminish because you didn't actually practice it. Question 5, using average atomic masses, calculate the number of atoms present in each of the following samples. So it looks like we have a variety of starting points, and it looks like we're all trying to go to atoms. So again, we can go grams to moles to atoms. Now, if we don't have grams, we have to find grams. So I'm going to start with this very first one. We have 1.71 grams of silver. I'm going to do my railroad tracks, and I'm going to go, look at this. There's my grams. Moles is going to go into this next spot. I'm going to draw one more line there. And then atoms is going to go in the last spot. So if you know GMA, Good Morning America, you can plug in your units across the top. And then you can find your units on the bottom because they shift. They're in the down box and they shift over 1. So if you have grams here, you'll write grams there. If you have moles here, you'll write moles there. And then you know the mole for everything we've done so far is 1. So you have a lot of the numbers already. The grams we have to get from the periodic table of elements. And the atoms is Avogadro's number. So the only one we have to look up is the mass of silver, and the mass of silver is 107.87 grams. And in my calculator, I'm going to go 1.71 divided by 107.87. I'm going to hit enter, and then I'll multiply it by 6.022E23. And I should get 9.54 times 10 to the 21st. Again, in WebAssign, when you enter this in, you'll use an E. You don't have to use that plus sign. That plus sign doesn't matter. And sig figs, 1, 2, 3 digits is what I started with, and therefore I ended with 3 digits. Let's do the next one. The next one gives you moles. Almost any time when you're given a problem, you're given moles, you're actually given a shortcut. So be very grateful. Say, oh, glorious mole, you have helped me out. So we have 0.0035 moles of copper. And we're trying to go moles to atoms, so that's just one bracket on here. Moles will be written on the bottom, and that's 1. And atoms will be written on the top. And atoms is always Avogadro's number, which is really difficult to shove into a tiny space. That's why I'm writing it at an angle. I'll put copper there just so I remember it's copper. The moles of copper and the moles of copper are going to cross cancel. And that number and Avogadro's number are next to each other, so I will multiply them. And I started with 2 sig figs, so I should end with 2 sig figs. So 2.1 times 10 to the 21st. And in WebAssign, again, you put an E. You don't have to put that plus sign in there. Well, I'm going to skip the next one. What I'll tell you briefly is just grams to moles to atoms. It's like the first one we did. But letter D is a stinker. It gives you kilograms, so make sure you read the problem. So we will go kilograms, 2 grams, 2 moles, 2 atoms. This one's a wee bit more involved. So 1.92 kgs of magnesium, kgs of mgs. And in my next box, I'm going to have grams. And then in my next box, I'm going to have moles. And then in my next box, I'm going to have atoms. Again, where did I get those? the grams, the moles, the atoms. If you know the pattern, you can just fill your units in along the top. And now to get my bottom ones, that one's always over 1. I don't write that. I see that in my head. Then I take that unit, put it on the bottom, shift it over 1. Then I put grams, it's askew from grams, and then moles are askew from moles. And the mole is always 1. And here, the grams of magnesium, I look from the periodic table, and it is 24.31. I'm a little hopscotchy on these. I don't always go left or right. I bounce around. And I know atoms is Avogadro's number, Avogadro, and 1 kilogram is 1,000 grams. You may have to look that up on a sheet, or you just may know that. And then I'm going to go through and cancel my units, kilograms, cancel kilograms, grams, cancel grams, moles, slices out the moles. I'm left with atoms. In my calculator, I'll do 1.92. This color's a wee bit faint. Give me not so faint. We've done purple. Let's do purple. So 1.92 times 1,000, because they're next door neighbors. Next door neighbors multiply. Then the next number is on the bottom, so it'll be divided by 24.31. Again, I would do that number times that number, hit enter, divided by 24.31 because it's on the bottom, and I would hit enter. And then the last number I'm going to multiply because it's on the top. And we should get 4.76 times 10 to the 25th atoms of magnesium. So on a test, you would want to write the number, you would want to write atoms, and you would want to write the element or the compound and put some type of geometric shape around it. We ended with 3 sig figs because we started with 3 sig figs. I'll briefly give you the pathway for these other 2 so we can keep on moving. This one's going to be grams to moles to atoms. And this last one, again, you got the shortcut because you have moles. It'll be just moles to atoms, and that'll be like letter B. And this one, again, is like either letter C or letter A. Similar, just you got to look up the different element. Moving right along. Question 6, a sample of potassium contains this many atoms. What amount of moles is this? So we are going from atoms to moles. We could do this. So this one's atoms to moles. And I'm going to have to squeeze this in right here. So 9.2 E21 atoms of potassium. And I remember it's GMA, but I can go backwards. I can definitely go from atoms to moles. It'll be 1 step. So I'll write my little tracks and definitely have mole here, and mole is 1. And on the bottom is atoms. And mole and atoms for individual elements is Avogadro's number, 6.022 E23. This number's on top, that number's on the bottom. I will divide them. And I have 2 sig figs, so I will end with 2 sig figs, 0.015 moles of potassium. Now the next question says, what mass is this sample? So you could start from the very beginning. You could start with the 9.2 E21 atoms of K, just like we did, and go atoms to moles. That's Avogadro's number. This is called speed writing. And the last one would be 1 mole of potassium is so many grams. I have to look up how many, the molar mass of potassium. That is one I don't have memorized. It is 39.10. And then I could go and slash out all those similar parts. I would do 9.2 E21 divided by Avogadro's number times 3910. You could also do the given number times 3910 divided by Avogadro's number. It's whatever works for you. And we started with 2 sig figs. We got to end with 2 sig figs, and it's that. Or you could have just taken the easier way, the 0.015 moles of K, and just multiplied it by the mass of potassium. And that would have been over 1 mole. That would have canceled, and that still would have given you that many grams. Lots of ways to do the same thing. In fact, you could use an alternate method to check your work to see if you were on target. Sometimes your fingers slip on the calculator and you get your final answer wrong. So question 7, a diamond contains this many atoms. What amount of moles is this? It's the same as the last problem, and then you're going to change it into grams. So you have 9.2 E21 atoms of carbon, and we're going to go to moles, so we'll go atoms. Hello, eraser. To moles. And 1 mole of carbon has Avogadro's number of atoms. So we're really just dividing by Avogadro's number. We started with 2 sig figs. We will end with 2 sig figs. And then to find the grams, we could just start with those moles of carbon. I write that down so I remember when I get to this next part. And 1 mole of carbon, the ratio of 1 mole of carbon has 12.01 grams. I got that number from the periodic table. And these two are next to each other. You multiply it and you get 0.18 grams of carbon. Question 8. Using average atomic masses, calculate the number of atoms present in each of the following samples. Okay, so you're again given the potpourri of units that you start with, but we're all trying to get to atoms. So remember, it's grams to moles to atoms. And this very first one, we have 1.71 grams of silver, and we're going to have to do the full meal deal. We'll go grams to moles to atoms. And then here's going to be grams of silver, and there's going to be moles. The number next to mole is almost always 1. And what we're doing here, you're going to have Avogadro's number for the atoms. And the silver, you got to look up the mass. I think we did this one, 107.87 grams. Got that from the periodic table of elements, remember? And I'm going to do 1.71 divided by 107.87, hit enter, then multiply by Avogadro's number, and I should get 9.5 for E21 atoms. Again, how you plug it in to WebAssign is E. You don't need that plus sign there, but if it is a minus, you have to put the minus in there because it's assumed that it's plus. Letter B is moles. You were given a present. I always call that a present. I love when I get moles. It's a shortcut. 0.0035 moles of copper. And that means we're just going moles to atoms. 1 mole of anything, even copper, has Avogadro's number worth of atoms. They're next to each other. You'll multiply. Started with 2 sig figs, end with 2 sig figs, 0.0035 moles of copper. If you end up with like a ginormous number or a super small number, sorry, not moles. Wait a minute, what's going on here? I'm cracked up. I'm writing the same dang number. 2.1 times 10 to the 21st. You should end up with a ginormous number here. I was off in la la land, sorry. Atoms of Cu. Next one, we're given grams again. 0.0035 grams of copper. And we're going to go to atoms. So we'll go grams to moles to atoms. The atoms is Avogadro's number. The mole is 1, and this is for copper. And you look up copper. We've done copper a couple times. Oh, no. Yes, 63.55. And this one is 1 because it's 1 mole. 0.0035 divided by 63.55 times that number. And we start with 2 sig figs, end with 2 sig figs, 3.3 times 10 to the 19th atoms of copper, Cu. Last one. This one gives you kilograms, so you're going to have to go kilograms to grams to moles to atoms. So we'll do 1.92 kilograms of magnesium, and we'll go from kilograms to grams. 1 kilogram is 1,000 grams. And then we will go from grams to moles, because that canceled the kilograms. 1 mole of magnesium has 24.31 grams for magnesium. And the last one is Avogadro's number on top of atoms for 1 mole of magnesium. And in my calculator, I'll do 1.92 times 1,000, hit enter, divided by 24.31, hit enter, then times Avogadro's number, hit enter, and it should equal 4.76 times 10 to the 25th atoms of magnesium. Hopefully this will help you do your WebAssign. Good luck. I'll see you again soon.